Hey folks, welcome to the NCEA Level 3 Calculus Complex Numbers paper from 2023. If you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourselves, and then unpause the video just to see how I go about answering the questions. So without further ado, let's get started. Alright, so looking at question 1 here, what we've got to do is we've got to try and expand the brackets. So that's all we're going to do here. So we've got 5 minus 2 root p minus 5 minus 2 root p again. Then we just expand the quadratic as is, and I think you simplify it and you should be good to go. So we got 5 times 5, which is 25. 5 times negative 2, that's going to be negative 10 root p. We've got another negative 10 root p. And then we've got minus 2 times minus 2, which is plus 4. And then square root of p times square root of p is going to be p. And putting this together, we're going to get 25 minus 20 root p plus 4p. And 25 plus 4p minus 20 root p. Yep, so this is pretty much all you need for this question to actually get an achieved. Let's go to the next question. So with the next question, what we've got is find the values of r. Quadratic equation has no real roots. Now, if it has no real roots, that means b squared minus 4ac, which is the discriminant, that has to be less than 0. And now what we're going to do is we're going to highlight all our important parts so that b is negative 4, a is equal to positive 4, and then we've got c, which happens to be 3r minus 2. So we've got negative 4 squared minus 4 times 4 times 3r minus 2, which happens to be the entire 3r minus 2 happens to be the c value, and all of this has to be less than 0 for it to have no real roots. So at this point we're going to expand the brackets. So we've got 16 minus 16, and we've got 3r minus 2 is less than 0. I'm not really going to expand that 16 and 3r, but instead what I'm going to do is I'm going to do it like this. So 16 3r minus 2, negative 16, is less than, because I'm bringing the 16 across to the other side, it's going to become minus 16. And I could do it this way here, where I'm going to do 3r minus 2. And remember that anytime you divide by a negative number, the inequality sign changes. And in this case, I'm going to get negative 16, which is already there, and that's divided by negative 16. So what we're going to get is 3r minus 2 is greater than positive 1. So carrying on with this, I've got 3r is greater than 1, negative 2 is coming across, so that's going to become plus 2. And I've got 3r is greater than 3, and then r is greater than 3 divided by 3. So for this case, the answer is going to be r is greater than 1. In terms of grades, we are looking at achieved for this question, and that's pretty much it for this one. Alright, so the next question, we've got two complex numbers, z and w, and it basically says the real part of z and w equals 0, then show that ap equals minus bq. Now, there's a part of me that's thinking this probably, I don't know, 10 years ago would have been like in the kind of like the excellence areas, but hey, here we go, merit question it is. Alright, so we've got z divided by w, so we're going to do that first. So z divided by w is going to be p plus qi divided by a plus bi. And anytime you get these types of questions, what you want to be doing is you've got to rationalize the denominator and then bring all the real parts together and then put all the imaginary parts together and then try and come up with some sort of connection to get to the proof that says AP equals minus BQ. So now first thing we're going to do is we're going to multiply by A minus BI because we want to rationalize the denominator. and this is what we're going to get. You know, now come to think of it, I don't think this was an excellence, because this is still fairly alright. Okay, so what we've got here, it's called a screensaver, but alright, so what we've got here is we've got to expand the brackets, and I'm talking about these two brackets here in the numerator and the denominator, and we've got to expand it just like a quadratic there, so we're going to end up with some messy terms here, but it should be alright. So we've got p times a, which is ap, then we've got minus pbi, then we've got plus a qi minus qbi squared, and the whole thing is of course divided by a squared minus b squared I squared. Now remember that I squared is equal to -1, so in the next line what I'm going to do is I'm going to replace all the I squareds with -1. So I'm going to get AP minus PBI plus AQI, because I squared is -1, -1 times that minus QB is going to become plus QB, and then for the denominator I'm going to get A squared. I squared is -1, so -1 times B minus B squared is plus B squared. Now once I get to this part here, what I want to do is I want to bring all the real parts together and the imaginary parts together. So I'm going to have AP plus QB plus AQI minus PBI. And I'm going to now put that all over A squared plus B squared. Now, I guess the parts that's kind of really important is we want to actually, we know that the real part of Z over W is equal to 0. So if that's the case, I'm just going to rewrite this like this. So I'm going to have AP plus BQ over A squared plus B squared plus AQI minus PBI, and that's divided by A squared plus B squared. Now, as I said before, the real part of this Z over W is equal to 0. So we can actually say this entire thing right here is equal to 0. If this is equal to 0, then we could actually say that AP plus BQ is equal to 0. Now we don't really need to worry about the denominator because this is pretty much, the numerator is the only thing that needs to equal to 0. And if that's the case, what we can then say is AP is equal to minus BQ. And basically what we've done there is we've actually proved that AP equals to minus BQ. So grades wise, this question is a merit question, and I'm going to take back what I said at the start of the question. I think this is definitely a merit question. I don't think this is an excellence question a few years ago too. In terms of what you must do to get to an achieved, you're looking at particularly this line to get an achieved. All right, so with question D, what we've got is, it's one of these repeat questions that seem to come every now and then. We've got one of the solutions, which is Z equals to 5 minus I. We've got to find the value of D, and then we've got to find the other two solutions. So what I'm going to do is I'm actually going to do the value of D first. Now, to find the value of D, all I have to do is I have to take the 5 minus I, which is Z, substitute it here, here, and here, and whatever this part is, plus D is equal to 0. So if I figure out what that Z cubed minus 8Z squared plus 6Z is, then I just invert it to actually get the value of D. Now to do this, what I'm going to do is I'm going to actually do this in the calculator, because trying to do this manually, you're going to be wasting a lot of time. And if you don't have a graphics calculator, I think some of the newer models do have complex numbers mode in them. So yeah, it's just handy to have one of these. All right, so we've got 5 minus I. So what I'm going to do is I'm going to go 5 minus, and I've got I right there. So that's my 5 minus I. And what I'm going to do is I'm going to store this as a Z value. Now, I know some people like to use answers, and that's absolutely fine as well. So what I'm going to do is if I go alpha Z, Z is always equal to 5 minus I. Now the reason I want to do this is because then I can do z to the power of 3 minus 8 z squared, and I've got plus 6z, and I'm going to put that right there, and so that's equal to minus 52. So what I might do though is I might actually write this down. So I might actually say z is equal to 5 minus I, therefore I'm going to put 5 minus I cubed minus 8 times 5 minus I squared plus 6 times 5 minus I plus d is equal to 0. All right, now remember, this entire part here, I've actually done this in the calculator, and that's equal to minus 52. So minus 52 plus d equals to 0, and then I can say that d is equal to positive 52. Now once I get d which equals to positive 52, I am pretty happy with what's happened here. Now to try and figure out the other two solutions of the equation, the first solution is given to you, z1, that's the first solution, which is 5 minus I. Now the second solution is always going to be the conjugate of it, which means you're going to get 5 plus I. And here's where you know, there's a couple of ways of doing this. Some people actually put this straight in the graphics calculator, and it kind of spits out the answers. So what you need to do is, where is it? I think I've seen complex mode here. I could be, there we go, complex mode. I'm going to go to a plus bi. And what I've seen people do is they actually go in here into equation, and then they go into polynomial, 3 degrees, and they actually put this entire equation here. So it's going to be 1, then they put minus 8, what do we got, minus 8, 6. We just figured out that d is equal to 52, so we're going to put 52. And when they solve this, they actually end up with all of those 3 solutions. Now, in the answer schedule, and I will show you folks this. If you look at the answer schedule, what they've got is the other 2 solutions found or d found, and then other 2 solutions found and d found. So, you know, if you find the, what is it? If you find the negative 2 and 52, you should actually get a merit, but there's nothing that says about showing working and so on. So I would just kind of put this in there anyway. So how do we actually figure out that last part, negative 2? Now remember, we're actually working with z cubed. So if we look at the first and last one, z cubed has a coefficient of 1, and the last value that we are dealing with is 52. When we factorize this, we are going to get z, and so we're going to have a minus in there, right? So something like this. Just bear with me in this one. So what's going to happen is we've got one of the factors, which is 5 minus I, second factor, which happens to be 5 plus I, and then the last one, which we don't know what it is. I'm just going to call it Z3. Now, what's happening here is we've got Z times Z times Z, which is equal to Z cubed. And then your right at the end, you've got negative 5 minus I times negative 5 plus I times negative Z3 is going to equal positive 52. And that's something that we just need to remember. Now, if that's the case, we can kind of say negative 5 minus I multiplied by negative 5 plus I multiplied by negative the Z, you know, the third solution, you are going to end up with 52. So once again, we're going to have to use the calculator for this. Now I've got 2 negatives there. I'm going to kind of be, but just let it be. But what I'm going to do is negative Z3 is equal to 52 divided by negative 5 minus I multiplied by negative 5 plus I. And let's actually work this out. So we're going to go back into our normal mode, and we're going to go 52 divided by, and in brackets, I'm going to have negative times z, which I already have, which is 5 minus I, multiplied by negative, this time I'm going to have conjugate of z, so I'm going to have to do that manually, 5 plus I, oh no, 5 plus I, where is I? Shift I, there we go. And when I do this, I actually get 2. What I'm getting is negative z cubed is equal to 2, which means the third root is actually going to be negative 2. And this is me showing the working, right, just to cover my bases. And if you look at the answer, what we've got, they've kind of done something very similar. They've actually went A, Z plus B and so on. You could do that method as well, but they're still kind of matching, what do you call it? They're still matching the values. That's kind of how you do this type of question anyway. So yeah, that's pretty much it for this question. So merit is when you find those, and that. So you got to find all three things there. For achieved, it's basically finding one of those three things. All right, so let's go to the next question. Now looking at this question, we've got a couple of complex numbers and then we've got a modulus in there. So, you know, even if you're like, I don't even know where to start this question, what I would do is I would substitute u and v. You know, straight away you can see that you've got a denominator that's got a complex number. So that means you've got to rationalize it. And then let's see what happens from there. So we've got 3 plus I, which is u, divided by 1 plus 2i plus k, and we've got the modulus of that is equal to square root of k plus 2. So as I said, the first step, what we're going to do is we're going to get rid of that 1 plus 2i. And the way we're going to do it is we are going to rationalize the denominator. So we're going to multiply by 1 minus 2i, and same with the numerator as well. And then we've got plus k equals square root of k plus 2. So at this point, we want to rationalize the numerator. We've got 3 plus I times 1 minus 2i. Now, I know that we can, you know, we can kind of expand this out, and it's probably a good idea to expand it. Should I do it in the calculator? No, I'll actually do this manually. So we got 3 times 1, which is 3, minus 6i plus I minus 2i squared, and that's divided by 1. I've got minus 2, what is that, minus 4 plus 4. So we're going to get plus 4 because we've got minus 4i squared. I squared is negative 1, so minus 4 times negative 1 is positive 4. Of course, let's not forget the k there. And all of this is equal to square root of k plus 2. Now let's simplify the numerator. We've got negative 2i squared, which changes to plus 2. So 3 plus 2 is 5. 5 minus 5i divided by 5 plus k equals square root of k plus 2. Now I could simplify this. So 5 over 5 is 1. That's going to be negative I plus k equals square root of k plus 2. All right, so now what I can do is I could actually look at that, what do you call it? I can look at this last part and I can actually work out what the modulus is. For the modulus, you kind of do the, what is it? The real part squared plus the imaginary part squared and then square root of that. But before I do that, I'm going to write this so that it's going to look like this. So I've got k plus 1 minus I equals square root of k plus 2. Now from here, this is my real part and negative 1 is going to be my imaginary part, and I want to work out the modulus of this. So this is going to end up looking k plus 1 squared minus 1 equals square root of k plus 2. So if you remember that you would always do, sorry, that should be negative 1 squared. Let me just redo that, plus negative 1 squared. So I've got the real part squared plus the imaginary part squared. That's going to give me my modulus. So I can get rid of the square root symbols here because there's square root symbols on both sides. So it's going to be x plus 1 squared plus 1 minus k plus 2. Now it's a matter of just expanding the quadratic and rearranging. So I've got k plus 1 squared, which is k squared plus 2k plus 1 equals k plus 2. So I've got k squared plus 2k plus 2 equals k plus 2. Then I've got minus k minus 2. So I'm going to end up with k squared plus k equals to 0. And I can factorize this. I'm going to get k plus 1 equals to 0. Therefore, I can say that k is equal to 0 or k equals to minus 1. All right. So looking at grades grades wise, final answer is actually worth an E8. So that is basically getting, both answers is getting you E8, not including k equals 0 as a valid solution. Oh, okay, all right. So they're basically saying that solution. So this is like if you ignore, like if you get up to that last line and then you kind of say, okay, can't be 0 or something like that, then you only end up with an E7. Merit is reaching stage 1, so that's going to be this right here is merit. For achieve, expressing u over v in the form of 1 minus I. So right here is where you're looking at getting that achieved for this question. So that's question 1 there, folks. On to the next one. All right, folks, so we're off to question 2. So question 2, what we've got is u over v in the form r cis theta. So to do that, we are going to get u over v equals q to the power of 6 divided by q squared cis 5 pi over 8 and minus 2 pi over 5. Because remember, when you divide two complex numbers in the cis form, the r values you treat it just normally, but the cis values you've got to subtract if it's divide, add if it's multiply. So with that in mind, we're going to get q6 over q squared is q to the power of 4 cis. Now we've got 5 pi over 8 minus 2 pi over 5. So I am just going to put that straight in the calculator. So 5 over 8 take away 2 over 5, and that's going to give me a syntax error, sorry. 2 over 5, where is it? There is it. There it is. So we're going to get 9 over 40. So in this case, we're going to put that as 9 pi over 40. And this right here gets you an achieved. And off we go to the next question. So we've got z is this, w is this, then find argument of, modulus of z minus w. So we're going to have 1 plus ki minus w is going to be, make sure you put this in brackets, folks, because it's very easy to forget that brackets, which kind of messes people up all the time. So then we've got 1 plus ki minus 7 plus ki, and here what we're going to get is negative 6 plus 2ki, and we want to find the modulus, so that means the real part squared, which is going to be negative 6 squared, plus the imaginary part squared, which is going to be 2k squared, and what we're going to get is square root of 36. 2 squared is 4, and then k squared is, well, that's just going to be that right there. There's nothing really you can do further than that. So grades wise, this question is worth an achieved as well. All right, so next question, we're looking for argument of z if 13z over z plus 1 is 11 minus 3i. So what we're going to do is a couple of things here. I guess what we want to try and do is isolate z by itself, and I think if we isolate z by itself, then we should be able to work out the argument. So I am going to do 13z equals 11 minus 3i multiplied by z plus 1. So I'm just cross multiplying there, and then what I'm going to do is I'm going to expand the brackets here. So I've got 13z equals 11z plus 11 minus 3iz, and I've got minus 3i. So I'm going to bring all the z's together. So I've got 13z minus 11z plus 3iz, and all of that is equal to 11 minus 3i. Now at this point, what I could do is I could actually say 13 minus 11z is actually 2z. So I'm going to get 2z plus 3iz equals 11 minus 3i. And here I could take z as a common factor, which is 2 plus 3i is going to be left over in the brackets. And then I'm going to get 11 minus 3i divided by 2 plus 3i. Now at this point, you know, if you don't have a graphics calculator, you could actually, you'd have to rationalize the denominator. But in this case, I know I've done a couple of examples of rationalizing denominators before, so I'm going to straight up go into using the calculator for this. So I'm going to go 11 minus 3i, and that's divided by 2 plus 3i. So when I do that, I am getting z is equal to 1 minus 3i. Now I need to get the argument for it, so I need to actually get the angle. You know, the couple of ways of doing this, you could actually put this straight in the calculator as well. I'm going to try and find it. So this was the first part that we did, 1 minus 3i. So to find out what you could do is if you just click on option menu, go into complex, and you've got argument there. And if you click on argument and then type in 1 minus 3i, and if you press equals, no, I've done something wrong here. Give me 1 second. Good old brackets. I forgot the brackets. So you've got to put brackets for argument 1 minus 3i. Now this answer is in radians. So if you would like it in degrees, we can just go down here, click on degrees, press equals again, and that's going to give the answer in degrees. So we can actually say argument of z is equal to negative 71.6 degrees. And in the answer schedule, they do give negative 1.25 radians as well. So you've kind of got both options there. But if you are like, actually, I don't know, my calculator can't do this, then you'll have to do this manually. And to do this manually, you would need to go 1 minus 3i. So that's going to be 1. That's going to be negative 3. And basically, what you're trying to figure out is this particular angle here. And if you look at it, what do we got? We've got 1 and 3. So you could use tan. It might work, but let's just try it out. Shift tan of opposite over adjacent, that's shift tan of 3. And that's going to give you 71.56. But because you're going anti-clockwise, sorry, not anti-clockwise, because you're going clockwise, it will be negative 71.56 degrees. That's just something to know as well. Grades wise, you are looking at a merit for negative 71.6. Reaching stage 1 is achieved, so this here is going to be an achieved grade. All right, so next question here. Now with this particular question, I know that I always do this in a slightly different way, but look, if you have a method that works for you, by all means stick to that. But the way I do this is I kind of convert this to r/s theta format first, and then once I figure out my first root, I just add whatever the angles that I need to add. So let me show you what I mean by. The first thing we've got is Z3 is equal to minus 64m to the power of 12. Now if I was to draw this particular complex number, it's got zero, well actually no, it's got no imaginary, it's just negative 64. So it's going to be somewhere here, negative 64m to the power of 12. So that means it has an angle or an argument of 180 degrees, and I'm going to purposely work in 180 degrees, sorry, degrees rather than radians. So I'm going to rewrite this as z cubed is equal to, and because it's a modulus, it's a positive distance, this would become 64m to the power of 12 cis 180 degrees. And with that in mind, z1, which is the z1 is going to be 64m to the power of 12 to the power of third cis 180 degrees, and that's going to be divided by 3. And that's just from your formula sheet. So if you do, it should be in the formula sheet, and that's pretty much what is going to happen here. So with this z1, now in some cases you don't even need to simplify this, but we are going to simplify it in this case. So I'm going to go 64 to the power of 1/3, making sure that I put that brackets, and then I'm going to get 4m. 12 times a third is going to be 4m to the power of 4, and 180 divided by 3 is going to be 60 degrees. So this is my first root. Now if you look at it, at no point in the question it actually says write this in radians. It just says write your solutions in polar form in terms of m, which we're doing here. Now this is z cubed. If it's a z cubed, what we're going to have is we are going to have 3 roots. which means there is a 120 degrees difference between each of those roots. So Z2 will be 4m to the power of 4 cis 60 plus 120, so that's going to be 180 degrees. And then Z3, which is the final root, is going to be cis 180 plus 120, which is going to be 300 degrees. And folks, with that, we are pretty much done with this question. Grades wise, all 3 correct solutions with appropriate justification. I don't know what justification would it be, but you've basically given the answers, 3 different answers. So that is going to get you a merit. Now, if you do just one of them correct, that's going to be an achieved. But for a merit, you're going to need all 3 answers. All right, so let's go to the next question. All right, so with question E here, what we've got is straight line equation y equals mx minus 1. Tangent to the locus of this, find the Cartesian plane of the locus and the value of m. Okay, so I guess the first thing we're going to do is we're going to do locus. So we're going to put down z is equal to x plus iy. That's always step 1 with locus questions. Then I've got x plus iy minus 2 plus I equals square root of 3. I'm going to collect all the real values, so it's x minus 2. The imaginary values, which is y plus 1, and square root of 3 is going to be separate there. Now, working out the modulus on the left-hand side, so I'm going to get square root of the real part, which is x minus 2 squared, plus the imaginary part, which is y plus 1 squared, equals square root of 3. And because I've got square root on both sides, I can get rid of them straight away. And I'm going to end up with x minus 2 squared plus y plus 1 squared equals to 3. So I'm ending up with a Cartesian equation of this locus, which ends up being a circle. But then we've got to figure out what this value of m is. Now, it says that it is a tangent. So remember that if it's a tangent, it's only touching the other curve just once, which means your discriminant has to equal 0. So with that in mind, because b squared minus 4ac equals to 0, we also have y is equal to mx minus 1. We're going to substitute that. So we're going to get x minus 2 squared plus mx minus 1 plus 1 squared is equal to 3. So all I've done here is I've put y equals to mx minus 1, and I've actually replaced the y with mx minus 1. So now what I could do is I could rewrite this as x minus 2 squared plus mx squared equals to 3. So I'm going to expand the brackets. I've got x squared minus 4x plus 4 plus m squared x squared equals to 3. Putting this all together, I'm going to get x squared plus m squared x squared minus 4x plus 4, and I've got minus 3, yes, equals to 0. So in here I can say that I've got x squared as a common factor, so I'm going to get 1 plus m squared x squared minus 4x plus 1 equals to 0. So far so good, but all I've done here is I've just worked out the quadratic equation. So now I've got to put in the b squared minus 4ac part, which should kind of help me try and figure out what that m value is. So just going to zoom that out here. So we've got b squared minus 4ac, which means we've got a, which is equal to 1 plus m squared, b, which is equal to minus 4, and then c is equal to 1. So we've got b squared minus 4ac equals to 0. So we've got negative 4 squared minus 4 times 1 plus m squared times 1 is equal to 0. So expanding all of this, we're going to get 16 minus 4 plus 4m squared is equal to 0. Then we've got 12 plus 4m squared is equal to 0. So 4m squared is equal to negative 12. What am I doing here? I'm missing up something here. I'm missing something here. I knew I did something wrong. That should have been negative 4m squared, because I'm like, no, this is ending up with a negative value. That's much better. So when I take 12 across, that's going to become minus 12. And then m squared is equal to negative 12 divided by negative 4, which means I've got m squared is equal to 3, and then m is equal to square root of 3. Awesome. I think that's pretty much it for this question here. Okay, so grades wise, they actually say in the answer schedule, don't penalize for plus or minus square root of 3, but you do get an E8 for getting right to the end. If you make a minor mistake somewhere, you could get an E7. Getting up to here, which part is this? 1 plus m squared. Okay, so getting up to this line here is going to get you a merit. And then for achieved, getting up to here, you're actually going to get an achieved. So lots of opportunities to get some good kind of cut marks here. But pretty much, folks, that is question 2. We go to the next one. All right, folks, let's get going with question 3. So we've got this polynomial here. When it's divided by x plus 3, the remainder is 30. Find the value of p. So basically what it means is that when we put f of negative 3, we are going to get 30. So that's what it really, that's what remainder theorem is. Because if it was a factor, then f of negative 3 would equal to 0. So what we're going to do is we're going to put 30 equals to 2 times negative 3 cubed plus p times negative 3 squared plus 7 times negative 3 minus 3. And so we're just going to do this fairly quickly with just the calculations here. So negative 3, that's 27, negative 54 plus 9p minus 21 minus 3. So putting it all together, what are we going to get? 54, 21, 75, 78, negative 78 plus 9p, and then 9p equals 30 plus 78. So that's going to give us 108. So 108 is equal to 9p, which means p is equal to 108 divided by 9, which equals to 12. So grades wise, achieved for this question. And we go to the next one. All right, so the next question, we've got u and v. Given that u over v is 3 plus 4i, find the value of n. So what we're going to do is we're going to do u over v first, which is n minus I divided by 2 minus 3i. Now, there's a couple of ways of doing this. And because we already know that u over v is also equal to 3 plus 4i, I could actually say that n minus I divided by 2 minus 3i equals to 3 plus 4i. Now I'll cross multiply. So I'm going to get 3 plus 4i multiplied by 2 minus 3i. At this point, I need to expand the brackets. And I've still got n minus I here. And I've got 6 minus 9i plus 8i. What's the last one? Minus 3 and minus 3. That's going to be... I'm missing something here. Minus 12i squared. So n minus I is 6 minus I plus 12. So n minus I equals 18 minus I. And as you can see, n is equal to 18. Because that's the real part for this question. So, grades wise, this is going to be worth and achieved. And again, there's multiple ways of doing this particular question. I guess this is just one of the ones I like doing because you can just kind of get it done real quickly. All right, so question C. We are doing x in terms of w. So all we've got to do is we've just got to rearrange everything so that x is on by itself on the left-hand side. So the first thing we are going to do here is I want to actually get rid of the square root symbol. And if I want to get rid of the square root symbol, what I'm going to do is, I'm talking about this square root, I'm going to square both sides. If I do this, on the left hand side, I will get 16 multiplied by 4x minus w equals, and on the right hand side I'm going to get 5 minus 8 root x times 5 minus 8 root x. Doing this, expanding the brackets, I'm going to get 25 minus 40 root x minus 40 root x plus 64. Root x times root x is just x. And here I'm going to expand the brackets on the left hand side, and I'm going to get 16 times 4, so that's going to be, what do we got? We got 16 times 4, that's 64x minus 16w. Okay, so now what I can see is I can actually see 64x on both sides, so I'm just going to cancel both of those out, and I'm going to simplify what's remaining, what's left over. So I've got negative 16w equals 25 minus 80 root x. I want to have x by itself, so I'm going to bring negative 80 root x to the left hand side to make it positive. So I'm going to get 80 root x is equal to 25, and then I'm going to bring the minus 16w to this right hand side, which will make it positive 16w. Then I can say root x is equal to 25 plus 16w over 80. I could factorize this, but I mean not factorize this, I could simplify this, but I'm just going to put it as 25 plus 16w over 80, and I'm going to put that as a square. Actually, I realize you can't really simplify that 25, 16, 80 anymore, so we leave this as it is. So correct expression for x is going to get you a merit, and getting to stage 1 gets you an achieved. So where are we up to for that? Okay, so getting to here gets you an achieved, but you need to make sure that this is written as minus 80 to get that achieved, because that's that simplification that's really important. Right, that's question C. We go to question D now. And for a second there, I thought that I hadn't actually copied all the questions, but here we go. So question D, what we've got is find the values of x and y. Give your answers in terms of p, where p is positive and real constant as well. So with this question, we've been asked to figure out what x and y is. So, and I guess the problem is x plus yi. It's actually in the denominator, so we've got to try and bring it to the numerator first. I think if we can bring it to the numerator, then we can match the real to the real values and the imaginary to the imaginary values. So what we're going to do is we're going to start off with 1 over x plus yi. And I've got 1 minus that 1 plus pi. So what I'm going to do is I am going to just, actually no, I might do this a long method so that you can kind of see how my working out comes out to be. Because I've got 1 here, and I know that 1 divided by 1 is still 1. And I'm going to multiply the denominator by 1 plus pi, and same with the numerator. I'm going to multiply it by 1 plus pi. So when I do this, I'm going to get 1 over x plus yi equals 1 plus pi. Now this is over 1 plus pi minus 1 over 1 plus pi. And I'm going to still keep going. I've got x plus yi equals to 1 plus pi minus 1, and all that is over the same denominator, which happens to be 1 plus pi. Now at this point, what I'm going to do is I'm going to simplify the numerator, which means I'm just going to end up with pi divided by 1 plus pi. So hopefully you're with me in this case so far. Now because we've got one fraction equals to another fraction, what we can do is we could actually flip the fractions. So we can actually just flip it upside down, which means we're going to get x plus yi divided by 1. I don't need to write that anymore. And 1 plus pi over pi. Because as you can see, I've simply just flipped the fractions. Because when you have one fraction equals another fraction, you can just flip the order of them. Okay, now what I want to do is I want to rationalize the denominator. So I'm going to multiply the denominator by pi, and I'm also going to multiply the numerator by pi. So when I do this, I'm going to get x plus iy equals pi plus p squared I squared. And now that whole thing is divided by also p squared I squared. So from here, I know that I squared is equal to -1. So I'm going to write this as x plus yi is equal to pi. I squared is -1, so that's going to be negative p squared divided by negative p squared as well. Now I'm going to separate the real and imaginary parts. So the real part is negative p squared over negative p squared, plus the imaginary part is pi over negative p squared. And I can now cancel out the p's, so I'm going to get 1 plus I over negative 1 over p, is it? Yeah, I'm going to get -1 over p. I should really move that to the numerator, which means I'm going to get 1 minus I over p. And from here, I can see that x is equal to 1 and y is equal to -1 over p. Now remember that -1 is right there. So that's where I get that -1 over p from. So pretty much, you know, I guess in that this line right here, I didn't need to multiply it by pi. I could have just multiplied it by I. Would have made a little bit more easier. Would have made it a little bit more easier, but that's okay. So grades wise, correct value for x and y is going to get you a merit. And then for achieved, you are looking at pi 1 plus pi. Oh wow, pi 1 plus pi. So right here is going to get you an achieved. All right, so let's go to the final question of this particular paper. Now this particular question, it looks like you've got to do the first part and then you got to insert the Z into the W part and then try and work out what the K is. So it's almost like, the way I call it is like, I think when we do the what is it? It's a bit of like an inception kind of question. But anyway, let's get started with this. So we've got Z plus 2I equals to IZ plus K. So let's actually try and figure out what is Z. So when we do this, we're going to have Z plus 2I equals IZ plus K. Then we can say that Z minus ZI equals K minus 2I. Now Z is a common factor. 1 minus I equals K minus 2I. And then Z is equal to K minus 2I divided by 1 minus I. Now that we actually have what Z is equal to, we can actually substitute that into W. Because with W, we can say W is equal to Z times 2 plus 2I. All I've done is I've just cross multiplied that Z with 2 plus 2I. But because I already figured out what Z is K minus 2I multiplied by 1 minus I multiplied by 2 plus 2I. And it's 1 minus I. I thought it was 1 plus I. I thought I could have just cancelled it straight away. No, unfortunately I can't. So what do I have to do? I have to rationalize the denominator. So I've got to multiply by 1 plus I. And also same with the numerator. I've got to multiply it with 1 plus I. So at the moment, you've got this really big thing that's happening here in the numerator, because you've got K minus 2I multiplied by 2 plus 2I multiplied by 1 plus 1I, and that whole thing is divided by 1 minus I and 1 plus I. So it's a bit of a ugly looking equation, but you know, this is part and parcel of the game. So I'm not going to touch the K minus 2I yet, but I am going to expand the brackets for these two brackets here, which means I'm going to end up with 2 plus 2I, and then I've got plus 2I plus 2I squared. And all of that is divided by 1, and then I'm going to get 1 minus I squared. And I'll take care of that in the next line. So I've got K minus 2I multiplied by 2 plus 4I, and then I've got minus 2, because I squared equals -1, and then -1 times positive 2 is -2. And in the denominator, I've got another I squared, so 1 minus minus of -1 is equal to 2. We're getting there slowly. W equals K minus 2I multiplied by 4I, and that whole thing is divided by 2. Now I am going to cancel the 2 out, so which means I'm going to get W equals k minus 2i multiplied by 2i, because I cancel this 2 with this 4 here, and I've got w equals k2i plus minus 4i squared. So then I can say w is equal to positive 4, because I squared is negative 1 times negative 4 is positive 4. So I'm going to get 4 plus 2ki. Now going to the question actually says the imaginary part of w is equal to 8. Now if w is equal to 4 plus 2ki, then we can say that because the imaginary part of w is 8, we can say that 2k is equal to 8. So we're going to say 2k equals to 8, and then k is equal to 8 divided by 2, which means we can finish off by saying k is equal to 4. Now, grades wise, correct value of k with, I guess when they say justification, you're talking about all the working out here. So that is going to be an E8. E7 is reaching stage 3, which is this. Stage 2 is merit, which is up to here. And for achieved, it's the Z part right there. Doing that is an achieved. So folks, that is pretty much question 3 there. What I thought I'd kind of start doing now is showing you this part right here, the cut scores. 19 points for an excellence. So, you know, it's actually pretty decent. You know, normally I would have said 20 is a good cut score for excellence, but this one is 19 to get an excellence, which is not bad. I mean, like, you get like 1 excellence question correct, and you know, a couple of merits in question 2, that's 6, and another merit question, it's a 5, so 6, 5. Yeah, that's pretty easy to get excellence in this if you think about it. So yeah, that's pretty much it for this question 3. Yeah, overall this paper wasn't actually too bad. I mean, like, there was a couple of tricky excellence questions, but I think, especially when I think about the last one, you can kind of just, you know, it was just like finding what Z is, putting into W, figure out what that is, and then figure out your K value. But overall, paper was solid. I enjoyed it. It's a good paper. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.